Hey y'all, welcome back to Alakazam Math Made Easy. In the last video, we went over the process to how to find the highest function value in a specific range. And what we're going to do in this lesson video is we're going to go over something that's kind of mildly tangentially related, but using the derivative to find a function or to find a value that makes a statement true. And we'll go into what those statements are in a second, right? So the mean value theorem states that if the function given is differentiable, which means can I take the derivative of it, and continuous, which if you remember means it doesn't have gaps or jumps or anything like that, between a given set of x values, you can use the equations below to find a value of x. So for example, x equals c that satisfies these conditions here, right? So the conditions say that these two relationships are true, and they're basically rearrangements of the same statement, but it's helpful to understand both, right? So f prime of c, right? You can approximate it by saying that f prime of c is the function value of b minus the function value of a over b minus a. And that's only true if c is between a and b. And we'll go through an example of what that actually means in a second, because it might be a little bit difficult to visualize, but this is what the actual formal language says. And again, remember how I said they're related. If I were to take b minus a, multiply it over to this side, I get f prime of c times b minus a equals that numerator. So they're the same thing. It's just sometimes it's easier to look at one versus the other depending on the problem. So a question would look like this, right? Find values of x that satisfy the mean value theorem for f of x equals some function over a given set of x's, right? So anytime something is written like on this, it means that x is between -1 and 2, right? So those brackets just indicate a range that include -1 and 2. So the first thing, remember, we have to verify whether it's differentiable and continuous, because if it's not, we can't use mean value theorem at all. The good news is they gave us a polynomial, which is always differentiable and continuous. So that's helpful. The issue you're going to run into continuity and differentiability with is fractions that you can't simplify to make sure the denominator is not 0. So that's the issue you're going to run into with continuity and differentiability. So obviously the next step, if you haven't figured out the theme so far, usually the second step of every process we've done is to take the derivative, right? So we're going to take the derivative. Remember, 3 to the front minus 1, 2 to the front minus 1, 1 to the front minus 1, right? So then we get 3x squared plus 4x minus 1. So that's our derivative. So now we're going to start looking at this actual formula here, right? So we have this, and we need to somehow relate it to the values we have of x, right? These values, but also the derivative, right? Because we have this f prime of c term. So what we're going to first do is, because it says f prime of c, and if you, it doesn't say it directly in the problem, but you know that we're ultimately going to solve for c, right? Because it says find the values that satisfy mean value theorem for that function, means we're finding this, right? So what we're going to do is, instead of leaving it as f prime of x, as the equation says, we're going to write it as f prime of c, which literally just means plug c in everywhere you find an x. So that's what we did here, right? So that's helpful. Now, what happens with the other side of that equation? Actually, for this case, we're going to end up using this equation, and this f prime of c is going to be on one side of that equation. So what happens with the other side? We have to take our two x values, plug them into the function from the original function, subtract them from one another, and then subtract the x values from one another. So that's what we're going to do. So f of 2 and f of -1 over 2 minus -1 simplifies to 12 over 3, which gets us 4. So now what we have is our left-hand side here, left-hand side, and our right-hand side here. and we're going to set them equal to each other, right? Because that's how it is up here. So now we have this function here. So that's basically a quadratic equation. Now we're back to algebra. So first step is to move everything to one side and set it equal to 0. So we're going to combine this -1 with the -4 that we would need to cancel that. So now we have this equation here. Doesn't look like there's an easy way to factor it. So let's just run through the quadratic formula. So that's what this is right here. Remember, x equals opposite b plus minus radical b squared minus 4ac. And then all of that is divided by 2a. So there's that. And that should get you two values for c, right? Because we have that plus and minus here. But what we have to make sure we do is, because it's asking for values of c that satisfy the mean value theorem between these certain x values, right? So because we're only looking for a value x equals c between these numbers, we have to make sure that the answer we put is also between those numbers. So our range is -1 to 2, which means -2.12 is outside that range. So we don't want to submit that as an answer. So our only answer that satisfies the mean value theorem between those 2 points is 0.78. And then again, you can just interpret that by saying at x equals 0.78, the mean value theorem is satisfied. So again, the theorems are kind of, I wouldn't say annoying, but from a student's perspective, it can kind of get a little bit annoying to have to deal with and have to navigate some of this formal language in writing. But try to understand it from a more conceptual standpoint. Like basically what it's saying is, if I take two x values and two function values, the derivative of a slope at that line can be approximated by, or at a point between those 2 points can be approximated by the slope of the secant line. So that's essentially what we're doing. And I can actually draw that out because that might be a little bit helpful. So if I have x equals a and x equals b, right? And I have some random function, right? What I'm saying is if I take the slope between these 2 points, right? At some point between those two, there's going to be a c where the tangent line, maybe I should draw it a little bit more accurately, where the tangent line, the slope of the tangent line at that point is equal to the slope of the secant line connecting those outside points, right? So the benefit of that is you can kind of narrow down your range to find a slope of a tangent line at a certain point. But basically what we're doing here, this piece is the slope of the secant line between x equals a and x equals b. And this part right here is the slope of the tangent line at x equals c. So basically all it's saying is, if I know that the secant line between these 2 points has a slope of whatever, there has to be a point between those two x values that also the tangent line has that same slope. So that's all this is saying. So yeah, if you learned something from this video, give it a like. If you want to stay up to date when I add new content to my channel, subscribe and turn on notifications. If you have questions, drop them in the comments and I'll answer them as quickly as I can. And as usual, best of luck.